Hello, welcome to the video on solving one-step equations. This will be a lesson on this topic, and let's take a look at our objectives here. So the first thing I want to do is define a one-step equation, and then I'm going to talk about something called inverse operations, and then we're going to use these inverse operations to actually solve one-step equations. Okay, so what is a one-step equation? Well, let me go ahead and actually write an example of one here. I have x plus 1 equals 3. Okay, so this is an example of a one-step equation. And let's just think about what this actually means. So x, remember in algebra, is a variable, represents a number. So really, we're talking about some number plus 1 is 3. So what's that number? Okay. Well, obviously that number has to be 2 because 2 plus 1 is 3. So therefore, x must be equal to 2. So we just solved this one-step equation. Now, as the name implies, to actually solve these one-step equations, it's simply going to require us to take one step. So I got this picture of this stairs here. And in algebra, the most basic type of equations are these one-step equations. So that's what we're going to learn. Okay, we're first going to learn how to solve one-step equations. And then in future lessons, we're going to talk about solving two-step equations. And then once you know how to solve these two basic type of equations, then you can really kind of solve anything. We are actually going to start learning the process and techniques to solve multi-step equations. But everything starts here with one-step equations. Okay? And the key to solving any equation, and of course one-step equations, is learning something called inverse operations, knowing what this is. So I'm going to introduce the basic concept of inverse operations to you, but we're really going to see how they work when we actually start solving these one-step equations. All right, so what's an inverse operation? Well, let's say I have this number 6. Okay, I'm just kind of making up a number here. So I have this number 6, and I go, you know what? I'm going to add 2 to it. I'm going to perform an operation, addition operation. So I'm going to add 2 to my 6. And I say, you know what? I don't like that. 6 plus 2, I don't want to do that. So how can I undo this operation? Okay, I just added 2 to my 6. If I want to kind of undo what I did, I can simply subtract that 2 away. Okay, and I'm left with my 6. Okay, so 6 plus 2 minus 2 gets me back to 6. So this undoing of something, okay, is an inverse. So when I added 2, to undo that addition, I use subtraction. So an inverse operation is an undoing operation. So for addition, it's going to be subtraction. Let's take a look at another example. Let's say I have 5, okay, and I say, you know what, I'm going to subtract 3 from my 5, and I go, you know what, I don't like that. I want to actually go ahead, I want my 5 back. So to undo the subtraction of 3, okay, I'm going to go ahead and add 3 back in, okay, and I get my 5 back, okay. So for subtraction, the undoing was addition, okay, the undoing operation. So here's our inverse operation. So for addition, it was subtraction. When we have subtraction, the inverse operation will be addition. For multiplication, it's division, and for division, it's multiplication. And we're going to see all these inverse operations in play when we actually start learning how to solve these one-step equations. But this is just the general concept of an inverse operation. It's an undoing operation. Okay, for addition it's subtraction, subtraction is addition, multiplication division, and division it's multiplication. And this is going to be key when we're solving one-step equations, or any equations for that matter. Okay, so when we're solving an equation, the goal is to isolate the variable, okay, to get the variable all by itself. So back in our previous example, we had x plus 1 equals 3, and we kind of reasoned to ourselves, okay, well, some number plus 1 is 3. We knew that x had to represent 2, okay, because 2 plus 1 is 3. So x equals 2 represents the solution to that equation. But x is all by itself here on the left-hand side of the equation. That's what I mean by isolate the variable, okay, to get the variable all by itself. So that's the goal when we're looking to solve any equation. So let's go ahead and actually start solving these one-step equations, and you'll see how inverse operations play a role. I think there's just no better way of learning than actually kind of start doing this and see this in action. And with practice, this will really become second nature. Okay, so x plus 6 equals 10. Excuse me. So I have x plus 6 equals 10. I want the x by itself. Okay, I want the x by itself. I don't want to add 6 to it. So what I'm going to do is I'm going to use an inverse operation to subtract that 6 away, because I just want the x by itself. So I'm going to go ahead and subtract a 6 away so I have the x by itself. But here is a big, huge point in algebra. So make a big note of this, okay? In algebra, when we're talking about equations, whatever we do to the left-hand side of an equation, okay, we must also do to the right-hand side. Okay, whatever we do to the right-hand side, we must also do the exact same thing to the left-hand side. So in other words, we have to treat both sides of the equation fairly. Okay, so if I subtract a 6 from the left-hand side of the equation, well, guess what? I have to balance this out by subtracting a 6 from the right-hand side of the equation. Now notice how I'm writing this. This is really important. Okay, see how I'm subtracting the 6 underneath the 6, and I have my 6 underneath this 10? Okay, this is exactly how I want you to write your steps when solving these equations. Really important. But this is our first one, so I want to just concentrate on the main concepts here. Okay, so what I did was use an inverse operation to subtract away this plus 6, so I want the x by itself. Now I'm going to add down, okay, in a column manner. Okay, so let's think about this. X plus nothing, okay, there's nothing underneath the x, is simply going to be x. Okay, plus 6 minus 6, okay, is 0. Okay, the 6's go away on the left-hand side, and that's exactly what I want. Okay, because I don't want any numbers next to that x. I want the x by itself. And then I have 10 plus a negative 6, or 10 minus 6, and that's 4. So I have x equals 4 as my solution. Okay, and that's it. You just solve this basic one-step equation. But let's go ahead and redo this without all these colors and everything in there, because this can be a little confusing. Okay, so I have x plus 6 equals 10. Okay, I want the x by itself. All right, so I'm going to do an inverse operation here. So I have plus 6, so I'm going to subtract 6 away from the left-hand side to get rid of that 6 next to that x. So I also have to do it to the right-hand side of the equation. And now I'm going to go ahead and add down, okay, in column format. Okay, and this is exactly the way you want to do it when you practice this stuff. So it's going to be x plus nothing is x, okay, plus 6 minus 6 is 0, and then 10 plus a negative 6, or 10 minus 6, is 4. Okay, one step. The only step I took was subtract 6 from both sides of the equation, use that inverse operation, and that's it. That's how you solve these basic one-step equations. Now, let's take a look at an example where we're using all the different type of inverse operations. That was addition and subtraction. So our next example is going to be y minus 8 equals negative 2. Okay, so here I have a minus 8 next to my y. Okay, I want the y by itself. Okay, remember, y equals whatever number is going to be the solution to my equation. So how can I undo a minus 8? Okay, if I subtracted 8 from this y and I want the y by itself, what I can do is use an inverse operation, use the opposite. Okay, so what's the opposite of a minus 8? That would be plus 8. Okay, now notice how I'm writing that 8 right underneath that minus 8. Okay, but remember that if I add 8 to the left-hand side of the equation, I also have to add it to the right-hand side of the equation. All right, so notice how I draw a little line like this. I'm lining everything up. So now let's go ahead and add down in our column format. So I get y plus nothing is y. Negative 8 plus 8 is 0. Okay, that goes away. Then I get negative 2 plus 8. So what's negative 2 plus 8? Okay, you got to know your positive and negative numbers here. So negative 2 plus 8 will be 6. Okay, so y equals 6. One step. Okay, one step to solve that equation. So Hopefully this is starting to make sense to you. Okay, remember the key is we're looking at what's going on next to the variable, and then we're using an inverse operation to get that variable by itself, to isolate the variable. Okay, so let's kind of back up here for a second. So in our first example, we had addition next to the variable, so we used a subtraction, inverse operation. In our next example, we had subtraction next to the variable, so we used addition. And now here, we have negative 2 times y equals 16. So what's going on here? So this is negative 2 times y. Negative 2 times y is multiplication. Okay, I have negative 2 times y. So remember back when I was talking about inverse operations, the inverse operation for multiplication is division. Okay, so to get y by itself, I'm going to use division. So I have negative 2 times y equals 16. So how can I get y by itself? Well, I'm going to divide whatever I see in front of my variable. So I have a negative 2 in front of my variable here. It's a product. Okay, they're being multiplied by one another. So if I divide negative 2y by a negative 2, okay, just that number, I'm going to get negative 2 divided by negative 2 is positive 1, right? Or 1y, or just y. But if I divide the left-hand side of the equation by negative 2, I also have to divide the right-hand side of the equation by negative 2. Okay, so now I'm going to get negative 2y divided by negative 2 is y, and then I have 16 divided by negative 2 is negative 8. Okay, so that's the solution. So, you know, right now you might be like, well, okay, I'm going to have to remember all these inverse operations. The key is practice. Okay, if you understand at least what's going on, the basic concepts, maybe rewatch the lesson again and take it slow in the beginning, but this will become second nature to you. But the key is this: you really have to master these one-step operations before you can take on any more challenging type of equations in algebra. Okay, so just think the opposite operation. So we had negative 2y. Okay, this is multiplication, so we use division to help us solve the equation in one step. Okay? All right, so let's take a look at our last example. So here I have 2/3 x equals 7. So this is going to be an example where we're going to use multiplication. Right? So we have 2 divided by 3x. Another way you kind of think of this is 2x over 3 equals 7. So we have a division situation going on here. So remember, if I have division, what's the inverse operation for division? Multiplication. Okay, so I'm going to show you how we're going to use multiplication to solve equations that have a fraction in front of the variable. Okay, so once again, I want to get x all by itself. Okay, that's isolating the variable. Okay, so x equals some number will give me the solution to this particular equation. So what could I do to this equation to get x by itself, 1x? Okay, well here, let me just show you, because of interest of time, I really want you to kind of get practicing on this by yourself. Excuse me. So if I have 2/3 times x equals 7, to get x by itself, if I simply flip this fraction around, okay, I have 2/3. If I flip it around and I multiply 2/3 by 3/2, what is that? What's 3/2 times 2/3? Okay, now remember how we multiply fractions. Okay, it's the numerator times the numerator over the denominator times the denominator. This is going to be 6 over 6, or 1. Okay, that's what I want. Okay, I want 1, or just 1x. So 3/2 times 2/3 is going to be equal to 1x, or simply x. Okay, we don't have to write that 1 in front of it. Okay, x or 1x means the same thing. But if I multiplied the left-hand side of the equation by 3/2, I also have to multiply the right-hand side of the equation by the same thing. Okay, so I have 7, or 7 over 1 times 3/2, and that's going to be equal to, remember, we're going to multiply those numerators over the denominator. That'll be 21 over 2. So let's just going to write it this way, 21 over 2. And that is our solution. Okay, so we had a division situation here we use multiplication, an inverse operation, to solve this one-step equation. All right, so if you understand these 4 examples, these 4 different techniques, you should be able to solve all these one-step equations. And if you master this, believe me, you're well on your way of mastering all type of equations in algebra. So let's go and wrap this up. So in review, one-step equations are the most basic equations in algebra. Okay, I've already stated that. Inverse operations, okay, they're kind of think of them as an operation that undoes something. Okay, so for addition, there was subtraction. For subtraction, there was addition. Multiplication, there was division. And for division, there was multiplication. Now, another thing that I want to stress here is that you could perform any operation to an equation, okay, as long as you do it to both sides of the equation. This is a real key principle in algebra, okay? If I have x equals 1, and I go, you know what, I want to multiply both sides of the equation by 5, you could do that as long as it's both sides, okay? So here I would end up with 5x equals 5. You really didn't harm your initial equation, x equals 1. You didn't really change it, you just made it look different, okay? It's still the same equation because you multiplied both sides of the equation by the same number, okay? You have to, whatever you do to the left-hand side, you actually have to do this exact same thing on the right-hand side. As long as you do that, you're going to be okay in algebra. All right, and last but not least, to solve one-step equations, isolate the variable by using these inverse operations. And we looked at these 4 examples. Okay, so if you understand those 4, then you're definitely ready to go ahead and start your practice and really focus on mastering these. Okay, don't guess. If you don't really quite understand what you're doing in the practice, come back to the lesson, rewatch it until you really got this stuff, fully understood, and then from there everything else will fall in place. Okay, so keep working hard, and we'll see you soon.